All right, so can you see my website now? Okay, you see my website? Okay. All right. So this is the website URL I sent you, kkunuke.com. I don't base myself on Canvas. I personally don't like it, but I know many classes do. But here's my website. Get to know it well. All right. Over here, Math 119. All right. And I just set this up this morning, early this morning. All right. So here's the general Zoom link, but of course you're here, so you got the class Zoom link. YouTube. So I am recording these things, and the non-copyrighted parts I'm putting up on YouTube, and I'm going to show you YouTube videos as well. So basically, I'm going to show you some short YouTube videos. We can chat along the way. We can talk and chat between videos. And then this whole thing, this overall class with some pauses for the copyrighted material, I'll try to put on my YouTube website. Although again, I might mess up sometimes. I hope I don't mess up. All right, Canvas. I don't do so much with the Canvas site, but a couple things you can do there. You can talk with each other and discuss with each other on the student discussion board. And also there's a link to NetTutor, which can help a lot. It's free online tutoring. But I myself probably won't participate in the discussion boards, but go ahead and discuss with each other. But that's all I use Canvas for. Otherwise, I don't really use Canvas. I'll email you your grade information. Pretty much I do things by email. And email me for questions or communicate with me during class. Okay, the syllabus, I'll go over the syllabus in just a moment. I email that out to you. Here's your homework, all right? Different versions of the homework, different print versions of the homework, all right? And this is all going to be due in September. I'll show you the calendar. So there's time for people to add the class. Lessons 1 to 10, due sometime in September. We're not going to have online exams. Do I hear some yays in here? No online exams, because I don't believe in them. I don't. Yay! Yay! All right. I don't like rewarding cheating. Yay. Okay. It's not that I'm an easy person. It's that I don't like rewarding cheating. I don't believe in online exams. All right. I have great homework assignments. Let's work on them together. Put in the effort. We'll make this happen. All right. And you'll learn statistics. I mean, we're twisting ourselves into pretzels. Oh, how do we stop them from cheating? Whatever. Work on my homework assignments. We'll get through it. Okay, my class notes. So the beautiful PDFs I'll show you, I have my PDFs up here. Okay, the links to my class notes. Okay, formula sheets. Back when I had exams, these are nice summaries of formulas that I would let students use. Excel templates. Actually, spreadsheet 0 is not on here yet. Yeah, various Excel spreadsheets I'll put on here so that, see, we're supposed to use statistical software and I use Excel. So I'll post my Excel spreadsheets on here, but don't worry. You don't need to have Excel or use Excel. I won't grade you on Excel, but still it's fun to play with these things. And it's nice to know that you can work some statistics in real life. Okay. There are friendlier programs like StatCrunch, but I don't want to even have you pay 13 bucks for that. But there is user-friendly software like StatCrunch out there. You can use it if you wish, but you don't need to use software in this class. I will show you Excel though. Right. Various class resources, test-taking tips for your other classes, right? Workshops, various handouts. You'll get a preview. I'll show you these in class. Some other handouts. I'll show you these along the way. These web links to tables and statistical calculators, I'll use those. R, that's free professional software, and I have some tutorials on here. I won't go over them, but hey, if you're a professional, you want to use R, I have some tutorials here. Register to vote. Side note, vote by mail. And just for your reference, some of my old exams and solutions, for your reference, they might help you on the homework, but that's just for your benefit. Some archives to my really old notes. So that's my website. So before I go to my syllabus, any questions about my website? I've had this for a while now. Okay, that's one reason why I'm not on Canvas. I had no time to put all my stuff onto Canvas. All my stuff's here. My pay website. I pay for it. You don't pay anything. All right. So let's take until 8:37 or so, and let's go over the syllabus. All right. And your continued presence in this class, it's like the human centipede episode of South Park. If you continue in this class, I assume you accept the terms and conditions. All right. Now, I assume you'll read this, but let's go over this quickly. All right, Math 119, statistics. All right. You can call me Ken. It's Kuniyuki, but call me Ken. All right. In my email address, remember, there's no I before the at. All right. That's like my my normal login. I'm pretty good at checking email, but bear in mind, I'm the assistant chair, and I'm pretty busy this week especially, so my response time may not be so hot, but I do check my email regularly. All right. Whoops, lost my chat for a moment. Oh, yeah, let's bring over the chat. Oh, come on. Whoops, whoops. All right, let me bring up the chat again. All right. Okay. Office hours, basically early evening. So for our class, starts about an hour and a half before class. But bear in mind, I need some time to set up, as you'll see. So I'll need some time to set up my laptop. Okay. And email me for an appointment so we can set up a Zoom room meeting, or we can just do email during my office hours. All right. Okay. My website, I showed you it. Of course, I'm assuming ready access to internet and email. I'm going to ask you to submit your homework to my Yahoo email account by taking scans or photo of your paper email. Or you can even send me a PDF of your typed notes. That's fine. Not too many people type them. You don't need webcams. I know some sciences require webcams. I won't require them. All right. As you saw, I posted a bunch of stuff on my website. If you want to form study groups, you can go through the Canvas site or email me, and I'll keep track of people. There's no required textbook. It's my notes. And I'll use Excel from time to time. Okay, and you saw the assigned homework assignments. Before I go on, any questions? Feel free to chat. Again, put on your chat thing. Additional resources. Okay, additional resources. You don't need any of these, but if you want additional books or websites, I have a listing here. StatCrunch. If you really want to use statistics and practice on it, it's pretty cheap. Accommodations and DSPS for students with disabilities. Bottom line, let me know as soon as possible, okay? And we can make accommodations. It helps that we don't have exams, right? Exams would have been a huge issue. Also college activities, right? Professional sports. Additional help. Like I said on the Canvas site, I don't have much there, but there is the discussion board and NetTutor, all right? Websites, like the stuff you find on my website. Each other, your fellow students, the Canvas discussion board can help. Tutoring, so check out their info on their website. Also NetTutor, which is free, 24/7 online, okay? And we may have some workshops. Star Trio for eligible students. And student resources. So if you click on this thing, then you can get a whole list of departments and resources. All right. Deadlines, standard for the 16-week term. The key deadline is Friday of next week, August 28th. So if you want to, well, you've enrolled in the class, but if you want to drop the class without anything appearing on your transcript or applying for refunds, the key deadline is Friday of next week. After then, something will appear in your transcript. It'll be a W up through the withdrawal deadline, Friday, October 23rd. After that, it's an evaluative grade, like an A to F. Any questions before I get to the nitty-gritty of grades? Any questions? Any questions? And by the way, during a video, if you ever need me to pause, you can put like a question mark or something, or just say, hey, you. You can unmute and say, hey, you. All right. But try to use the chat feature, okay? We're great with chat. I don't think students want to hear, hey, you. That's a Pink Floyd song. All right, grades and assignments. Your course score will be out of 600 points. 600 points is 100%. I think there's like a 3-point extra credit opportunity later in the course. Homework will be 5/6 of that. 100 points for each of 5 submissions. Okay, so again, you saw the homework assignments. Your homework grade, which will be out of 100 points each, will be a combination of overall completeness. So I'll look over, saw that you did the homework solutions with integrity, and you did it the way we did it in class. And also your solutions, because it's often not just answer only. Sometimes it is, but sometimes I do want to see how it worked out solutions, okay? And I'll grade a selection of problems, okay? I don't have time to grade everything, but I'll take a selection of problems and grade them. It's like a sampling. That's like a good statistical grading technique, okay? I'll grade a subset of the problems. All right, now this will help a lot. Folks, if you're engaged in the class, you can do well. I will go over the solutions and answers in our homework sessions, all right, which will be recorded. These sessions, however, these sessions will be very difficult to understand if you don't keep up, okay? If you haven't studied the material and you haven't basically completed the homework, then you'll get very lost in these homework sessions. So obviously, you want to do the homework along the way, keep up, try to learn the material as best you can, and then all will be made well in the homework sessions where I go over the solutions and answers. But if you don't know your stuff, you could get lost. It's expected that students will be knowledgeable enough to keep up with the homework sessions. So keep up. Although you're strongly encouraged to do problems as soon as you can, homework will typically not be due until this time, midnight, the end of the day following the homework session. So for example, if we have a homework session on a Wednesday, we mostly do. If we have a homework session on a Wednesday, then the homework doesn't have to be emailed me until midnight the following Thursday, right? The next day, Thursday. Although try to be prompt because there might be an email snafu, okay? So you want to make sure your email goes through. I expect students to either write out or even type their solutions to problems on separate paper and then email scans or photos to my email address. If you type something, go ahead, PDF it, but that's very ambitious. All right, bottom line, email, and you send it to my email account. You do not have to rewrite the problem statements, okay? It's there on the assignments. You don't have to copy them unless you want to, unless it helps you, if you wish. And don't worry about storage capacity. My Yahoo email account, not my SDCCD account, but my Yahoo email account has unlimited storage capacity. So don't worry about that. If you send me something that's 3 gigs, that's fine, okay? You might have trouble on your end, but don't worry about how big your files are. Please just make sure they're in order, okay? Expect late homework to be penalized. You can read that. So be on time. And the last homework has to be turned in on time, all right? Because I got to turn in grades. I can't wait too long. Make sure you turn in your solutions to the homework problems in the correct order, right? So like lesson 1, 1, 2, 3, whatever, all right? So there's no confusion, and I don't get confused, and you can get all the completeness points. Now, if you have some trouble with particular problems, you can leave some space. So, you know, you do number 1, number 2. If you have a hard time with number 3, leave some space, do number 4, and then you go, oh, wait, I know number 3. Go back to it and fill in the space. But do try to turn in your solutions to the homework in order. Otherwise, I may have a hard time judging if you really did it all. Clearly separate sections. Write your first name, last name, and Math 119, either on a title page or the upper right-hand corner of the first page. Show work where appropriate. Points may be deducted if you're incomplete, illegible. If you systematically copy, I encourage collaboration, okay? But systematic copying, that constitutes cheating. You might be wondering, if there are no exams, how can we cheat? It's if you systematically copy. That's cheating. You're just not thinking, you're just copying someone else's stuff. That's cheating. Or going online and just copying everything without thinking. Turning in late's a problem, right? You need to adhere to good form and procedure in class. Although I'm open-minded to other techniques, but whatever you do, show me your thought process, all right? And make sure, and don't submit work that's insufficient, messy, or unordered. Questions, because the homework is key. 5 homework solutions. 5/6 of your grade will be based on the 5 homework submissions. Any questions? Any questions? And feel free to ask me questions along the way. Like in chat even, right? What's the meaning of life? 42. All right. The remaining 1/6, bonus points if you got that reference to Hitchhiker's Guide. Kidding. All right. How does the due dates work again? All right. So due the midnight, the day after the homework session. I'll show you the dates of the homework sessions. First one will be in September. Okay. Class participation. 100 points out of 600. Okay, now, and this may involve participation in class, including Zoom chat, although frankly, that might be hard for me to track, but okay, I should, oh yeah, I got to save the chat. That's right. Save the chat. Okay, so, all right. Okay, office hours, email, homework sessions, in-class activities and exercises. Maybe the Canvas discussion boards, I might check in, see who's participating. And if I remember your name, that's a great thing, right? Your grade in this class will be affected as follows. Here's the thing. Everyone will get at least 90 out of 100 points, okay? So this class participation score, whatever this thing is, right, will not harm your letter grade. It will not harm your letter grade, okay? The remaining 10 points can help you though. Okay, if I really noticed you participate a lot in class, I can give you up to 10 points that will help you. And if you end up near a borderline, right, like 88 or 89%, then I could use this principle to push you up. I see questions in chat. Do we have any chances to improve grade after our submission? Last semester I allowed it. This time, my answer is probably no. So when you submit, right? How many work problems would we have for each homework assignment? Oh, you'll see on my website. It's on the PDF files on my website. Okay, the homework assignments are there. I don't do that MyMathLab stuff. Hitchhiker. All right. All right, so 90% or better than A and so forth. I don't reverse curve. I might lower these a little bit. Class participation will help a lot. All right. You might be able to take the class pass, no pass, but check your program requirements. Week 5 is the deadline. All right, the grades. Any questions? The grades. All right, going on. Academic integrity. Basically, don't cheat. Collaboration outside of class is encouraged, but again, systematic copying is forbidden. Then I may have to consult with you before assigning points. As far as the internet goes, online resources, use them judiciously. I mean, sure, if you find a great YouTube video that teaches you stuff, awesome. Okay, I encourage use of online resources, but don't go to any websites that help you cheat or anything like that. Like, how do you do this? And you don't have to think or anything. It's one thing to ask for tutoring. It's another thing to say, do this problem for me, you know? All right, but so anything that enhances your learning, watching other YouTube videos, that's cool, all right? And stuff I did in prior terms may not apply now, okay? So don't say, well, my friend did this or that. Don't say that, okay? It's a new ball game this semester. And you can read this, classroom behavior and student code of conduct, All right, preparations, well, you're on the internet, okay? And of course, you might want to have your homework handy so we can talk about it. You should have a scientific calculator handy to do work. It's good to take maybe some notes in class, although my notes are online and they're free. And I'm not going to say in the middle, it's $10. I won't do that to you. Your email carrier might, but I won't. It's your responsibility to add, drop, or withdraw. So don't expect me to drop you or whatever. It's your responsibility to know your status in the class. Again, keep the deadlines in mind. And Mesa may not be liberal with lateness. I'm never late, so don't worry about this 15-minute thing. Check assist.org to see if you really need to be here. The official stuff, you can read this, official stuff I had to put in the syllabus. Mesa Journeys, okay, this is like a guidance counselor that can take you to services like veterans. No, I'm not gonna post grades, I'll email you grades. Notes and class contacts, so you can work with each other. Yeah, I don't trust Canvas. All right, internet technology. Well, you're here in Zoom, all right? You can make appointments for office hours. In my office hours, I'll be checking my email. Oh, and by the way, If you speak or chat publicly, I guess I should have said this early. If you speak or chat publicly in class, it's assumed that you're giving consent. If you don't give consent, then try to let me know. Sometimes I turn off recording though, but it's assumed that you consent to being recorded. I don't intend to publish chats, but it's not out of the question. Okay. So again, read this. Here's my YouTube channel, so you can check out my videos, including class sessions. Canvas, where I have the discussion boards and NetTutor. The very tentative schedule. So, now, this is subject to change, all right? These are the various lesson numbers. Lessons 1 to 10 will make up the first part of the class. Here's the deal. Wednesday, September 2nd, I intend to, discuss the homework with you. You may have homework questions. And then there's a holiday, Labor Day, September 7th. On September 9th, I will very quickly go over the answers. Very quickly. Make sure you're prepared by then, because I'm going to go over the answers very quickly. All right. I do hope to record this, but sometimes I forget. So try to make it if you can. All right. If I forget, I reserve the right to forget, Okay. So that's key. And then as someone was asking, okay, that's Wednesday, September 9th, when I'll go over the answers for homework 1, lessons 1 through 10. And then Thursday at midnight, Thursday, end of the day, midnight, that's when the homework's due. But try to submit early so that in case there's an error, we can take care of it. Okay. Why don't you trust Canvas? Yeah, we've had some issues lately. Don't be paranoid. I mean, your instructors will use Canvas, but I'm especially paranoid because I've seen some errors here and there. But no, I wouldn't say be paranoid. I'm just paranoid. I love my website. I love my website. I've had it for 15 years. Okay. Do I ever post the answers? No. See, here's the thing. I want you to come to class. I intentionally do not post answers. I want people to come to class. Now, if you want to email me and chat with me or email me intelligently, and you're thinking, hey, professor, I'm thinking this, then I can guide you along. But remember, don't just ask, can you do number 9 for me? No. Okay, tell me what you're thinking. All right, let's have a conversation. That's the plan. Okay, so again, the homework sessions correspond to the 5 homework assignments. And I got to figure out the submission date for the final. It could be the day after still, but in general, the submission deadline is the midnight, the day after the homework session. I guess they're almost all on Wednesdays, except this one and this one. All right, we're at 8:36. Any questions? The website and the syllabus. Any questions? All right. Okay, so let's get right to it. Again, these are on my website. Okay, well, I'll play the YouTube videos. These are on my YouTube site. Okay, let's do it. Remind me if the closed captioning is not showing. They should be closed captioned. All right. Let's do it. Okay, now as I play the video, again, chat's on. Hey, folks, I know you're going, well, can't we watch your YouTube videos asynchronously on our own time? True, but in class, you can chat with me, and we can chat and discuss between the videos. So it helps to come to class. Again, I'm keeping that chat feature on. Ask me in chat, okay? Even stuff about the syllabus. Let's do it. Let's keep that chat on. All right, keep that chat on. Let's play. Statistics. Let's begin. So in lesson 1, we're going to start with an introduction. What is statistics? So here's an overview of the overall structure of the course. So we're going to look at the anatomy of a statistical experiment. For example, if you're taking a political poll or doing a study on coronavirus vaccine. First of all, you need to design an experiment, and as part of that, you have to carefully define the population. You collect the data. Don't worry, in this class, I'm not going to have you go out and grab people. That's not safe. But you collect data, and we'll talk about various ways you can collect data. Third, we take the data and we describe it. That's the art of descriptive statistics, which many of you had in high school. And then by using the tools of probability, which is a whole unit in and of itself, we interpret the data. And that is the art of inferential statistics. That's where the magic really comes in. And that's where pure math professors get kind of creeped out. Okay, so let's talk about the idea of designing an experiment, collecting data, describing data, and then interpreting it. This picture here. All right, so first of all, as part of designing the experiment, we have to carefully define the population of interest. So for example, let's say that we're taking a political poll. We want to know what percent of registered voters in California support President Trump. Granted, a state like Wisconsin might be more interesting. So the population of interest, which we say has size capital N elements or members, in the state of California, it would be in the tens of millions. The population could be, for example, all adult Americans, maybe all registered voters in California. And again, we need to carefully define what these populations are. So for example, if you're interested in what's happening with all adult Americans, well, a key question is, do adult Americans include undocumented immigrants? That was an important controversy with the census recently. If you're dealing with all registered voters in California and you want to know what percentage of them support President Trump, granted, probably lower in California than in Wisconsin or in Mississippi, but you can ask what percent of all registered voters in California support President Trump. Well, instead of registered voters, you might want to ask about likely voters. In a national poll, you might want to ask about likely US voters. And different polls might use different models for the purposes of screening poll respondents. So what constitutes a likely US voter? A Republican poll might have one definition, a Democratic poll might have a different definition. That's why we suspect that some Republican polls might be biased towards Republicans, and some Democratic polls might be biased towards Democrats. Well, more objectively, you could look at issues like voter enthusiasm and voting history. So for example, it's often assumed that someone who voted in a midterm election or in the last presidential election might be more likely to vote in the upcoming presidential election. So defining the population of interest is important. So from that population, we might draw a sample, because it would take way too long to ask every registered voter in California what he or she thinks about the election. If we do that, that's called a census. So for practical purposes, we draw a sample. And within the sample, we describe the data. So from the population of tens of millions of Californians, registered voters in California, well, we draw a random sample of maybe 1,000 registered voters in California. And we can describe that data. And then based on that sample data, here's the tricky part, the inference. The inference. Where based on what we see on our sample, we try to infer what's happening in the overall population. So for example, if we have a poll of 1,000 registered voters in California, and if we find that 35% of the registered voters in our poll support President Trump, what does that say about the true percent in the true population of interest among all registered voters? Is the actual percent going to be 35%, or could it be 40%, 45%, or even a majority? So this whole issue of designing the experiment where you describe the population carefully, collecting data to form our sample, which could be a sample of poll respondents or subjects in a scientific study, or maybe some sample products on an assembly line if you're testing products for quality control. From that sample, so we collect data to form the sample. Within the sample, we describe the data. We find that, for example, 35% of the registered voters in our poll support President Trump. And then from that, interpreting the data, inferential statistics. What can we say about the population of interest? Okay, so next time we're going to talk about the distinction between population data and sample data and look at some examples.
Okay, so, well, okay, hold on. Oh, you know what? I should go to my own YouTube channel.
Yeah, okay. Oh, okay. Yeah, give me a moment. I got to go to my own YouTube channel. We don't want random ones. Okay, playlists. Okay. And in the meantime, I'm gonna let's answer some questions in chat. All right. Yeah, 11:59. Yeah, I don't blame them because noon, well, midnight especially is confusing because you don't know which day exactly. Submission through email only. Yes, let's say email. Although, if you really love Canvas, I have gotten them through Canvas, but email is more straightforward. So will all lessons be uploaded to YouTube? That's the plan, yes. All right. Any other questions? Any other questions before we go on? We're continuing with lesson 1. I like to break these up into like 10-minute videos or so. All right, let's do it. Hold on. So if we go back to our schematic,
Let's go. Okay.
Hi everyone, let's continue with our discussion of population data versus sample data. So if we go back to our schematic here, maybe the population of interest is all registered voters in California. In 2019, there were about 20 million of them. But we don't have time to talk to every registered voter in California. We don't have time for a census. If we manage to collect data from each element of the population, we have a census. But the problem is that a census is often impossible or impractical. Now, actually, we are trying to conduct a census in America in the year 2020. That's mandated by the Constitution, where we try to contact every resident in the United States. That has been the source of controversy because the issue of undocumented immigrants has been a controversy with respect to the Trump administration. But often a census is impossible or impractical. So we collect data on only some elements of the population. And these elements make up a sample from the population. So for example, of the 20 million or so registered voters in California, we might take a random sample of 1,000. We'll talk more about this later. So capital N, the population size, might be about 20 million, but little n, the sample size, might be only about 1,000. In fact, 1,000 is pretty typical for a poll. That's a reasonable sample size for a poll. And we can actually talk or email all 1,000 people. Okay, so let's talk more about the idea of a census. I got this data from Wikipedia. Not generally recommended, but I think I was safe here. Example 1, a census with population data, presidents' ages. So here, I consider the 45 US presidents through Donald Trump. Cleveland is counted twice. We want to know how old they were when they became president, when they were inaugurated. So with the help of the internet, Wikipedia, we can quickly conduct a census and obtain all the necessary population data. So here I have the order number for each president. George Washington, you may remember, was number 1. The last name here, and the corresponding age on becoming president. In fact, the oldest was in fact number 45, President Trump, at age 70. If Joe Biden wins in 2020, then he would be number 46, and he would have the oldest age. Donald Trump is trying to stay number 45. Okay, so this is an example of a census where we have all of the elements of interest, all the US presidents, and their corresponding ages. The presidents would be referred to as the observational units. The ages make up the actual population data, the numbers that we might want to manipulate. Okay. Now, let's talk more about the idea of population data versus sample data. All right. So example 2, a statistical experiment using sample data, a poll. So let's say the great nation of Fredonia, it's made up. The Marx brothers joked about this. Actually, there were surveys, joke surveys sent out to actual Congress people. What do you think of our policy towards Fredonia? And they didn't know it was a made-up country. They made fools of themselves. All right, the nation of Fredonia has 100,000 registered voters. We would like to know the proportion of registered voters in Fredonia who want to re-elect the president. So the proportion might be something like 0.5 if it's 50%, or 0.40 if it's 40%, for example. The Fredonia News Network, FNN, randomly calls 1,000 registered voters. Well, as you might suspect, you can figure out which is capital N and which is little n. But FNN randomly calls 1,000 registered voters in Fredonia and asks them their opinion about re-electing the president. 570 of them, or 57%, say that they support the re-election of the president. So take a moment now and try to answer these 6 questions. A, what is the population of interest in this experiment? B, what is the population size, capital N? C, what is the sample in this experiment? D, what is the sample size, little n? E, describe the sample results. And F, based on the sample results, what might we infer about the population? I'll give you a minute to look this over.
So take a minute to think about this. In the meantime, I'll chat.
All right. So first of all, what is the population of interest in this experiment? It's all registered voters in Fredonia. Those are the elements we actually care about, all registered voters in Fredonia. What is the population size, capital N? Well, there are 100,000 registered voters in Fredonia. So capital N is 100,000. If you want units, voters maybe. C, what is the sample in this experiment? The sample consists of the registered voters in Fredonia who are called by FNN, the Fredonia News Network. So they're in the poll. The sample size, little n, is 1,000 voters. That's the sample size in our poll, or FNN's poll. E, describe the sample results. Well, 570 of the 1,000 called voters, or 57% of them, say that they support the re-election of the president. So the sample proportion is 0.57. F, based on the sample results, what might we infer about the population? Well, based on the poll, we might infer that about 57% of all the registered voters in Fredonia support the re-election of the president. But when I say about 57%, can we make that a bit more precise? We're going to talk about that more when we talk about inferential statistics later in the course. Okay, population data versus sample data. In lesson 2, we're going to ask, well, how do we pick them? How do we come up with a sample? How do we get from here over to here? How do we get our sample? Sampling methods. How do we pick them? All right, that's next time.
All right, so I'm going to do something daring. I'm going to pause the video and show you a simple random sample. Here's an example of a simple random sample. Lesson 2. Closed captioning. All right.
Hey everyone, so how do we get this sample from a population? All right, lesson 2, sampling methods. How do we pick them? And what do we ask? Part A, what makes for a good or bad sample? When selecting a sample from a population, we want the sample to be representative of the overall population. We do not want the sample to be biased in one way or another. Now, a common problem in practice is the use of overly homogeneous or sort of similar samples in which the elements within the sample are much more similar than is the case with the overall population. For example, you wouldn't want to restrict your sample to a single state if you wanted to study the national popularity of the president. So for example, if you wanted the proportion of likely US voters who support President Trump, you don't want to focus on only voters in Utah, for example, because the population in Utah is too homogeneous, it's too internally similar and not diverse enough, and also Utah is a very Republican state. You also wouldn't want to restrict your sample to just your neighborhood or to the next 5 people you happen to talk to. So for an accurate survey, you don't want to go out and just grab the first 5 people you meet. Don't go out and grab people. Anyway, that's not polite or safe. These are examples of convenience sampling, which is usually not as accepted as the following sampling methods. So in general, we're going to avoid convenience sampling. Instead, we're going to advocate things more like simple random sampling. And in fact, this is usually the assumed method of sampling. We typically assume that a sample from a population is a simple random sample, or SRS. When constructing an SRS of size little n, remember, little n is the sample size, each group of n elements in the population is equally likely to be our selected sample of n elements. So for example, simple random sample, SRS. If n equals 4, if the sample size is 4, then the 2 samples below, each represented by 4 black squares, are equally likely to be selected. So let's say that we have a town where I guess the people are all spread out in a nice grid here. So each small square here represents a person in the town. Well, these 4 people selected in black here are just as likely to be selected as these 4 people in black here. That would be the case for a simple random sample. So if we wanted an SRS of 4 people, this group of 4 people, the black squares here, are just as likely as these 4 people, which is as likely as any other group of 4 people. So any group of size little n is equally likely to be picked. So for example, here's the census of presidents' ages that we saw back in lesson 1. Now, even though the census was attainable, still you might not want to look at 45 numbers here. This might seem overwhelming. So instead, we may prefer to look at an SRS, a simple random sample, of size, say, n equals 5. Little n equals 5. And we could use a random number generator to pick 5 distinct or different random integers between 1 and 45. Remember, an integer is something like 1, 2, 3, 4, and so on. 2.5 is not an integer. Pi is not an integer. We could then construct our SRS by selecting the 5 corresponding presidents based on these 5 integers between 1 and 45. And we're assuming that we're sampling without replacement, meaning that we cannot pick the same number twice. So just one note here. Okay. Without replacement, better shrink this. Without replacement, that means don't select the same item or observational unit twice. Here, don't select the same president twice, although you could select Cleveland twice, potentially. All right, anyway, 5 distinct or different random integers. So we're sampling without replacement. And then we pick those corresponding numbers from the order sequence and get the corresponding presidents. So for example, if 1 is selected, we get George Washington as our observational unit that's selected, and 57 is the observation, the data point, 57 years. So let's say that a random number generator gives us the 5 integers between 1 and 45, 4, 11, 13, 24, and 34. Here, I've sorted them. So that means that we pick number 4. We pick up number 4, James Madison, who was 57. Number 11, James K. Polk, who was 49. Number 13, Millard Fillmore, who was 50. Number 24, one of the Clevelands. Cleveland number 2, who was 55 then. And number 34, Dwight D. Eisenhower, who was 62 then, when he became president. So our sample data would be 57 years, 49, 50, 55, and 62 years. All right, so the 5 shaded entries. And the data here, 57, 49, 50, 55, and 62 years. Technically, it's good to state the units, years. Now, there are programs like StatTrek that can be used to generate random integers. It's broken right now. But we could also use Excel. So I'll show you how to use Excel. Now here, I'll show you how to use Excel to generate a random integer between 1 and 100. So the instruction you would use would be equals. That's often the case when you want Excel to compute something. Equals rand between. Pick a random integer between a low. I apologize. It should be bottom comma top, I guess. Sorry, bottom comma top. All right. So the bottom or lowest possible number integer is 1. The highest possible number, the highest possible integer up is 100. So equals rand between 1 comma 100. By the way, I don't expect you to use Excel in this class, but I'll show you how to use it. We get a random number, 6. So then we pick John Quincy Adams. Okay. Well, that's between 1 and 45. Here's between 1 and 100. If you repeat this, you could repeat this a bunch of times. And by the way, this top cell also changes. Right? If you repeat this, you can get a bunch of random numbers. Although in principle, you could get duplicates, actually. That's sampling with replacement. And then if that's the case, then you want to throw out a duplicate and get another number. Okay, so that's one way you can get random numbers between a lowest possible integer and a highest possible integer. For the president's case, it'll be rand between 1 comma 45. All right. Now, by the way, random number generators, such as the one on StatTrek or Excel for that matter, or StatCrunch, are really pseudo-random number generators. An algorithm really determines what numbers are selected. So they're not truly random numbers. There is an algorithm. However, for all practical purposes, they're random. Now, in a program like StatCrunch, sometimes the professor wants the students to come up with the same pseudo-random numbers that they're getting, that the professor is getting. So the professor might say, okay, students, use the seed I used, which was, say, 17335. Okay? And then all the students would then enter that number, 17335, and then they would get the same numbers that the professor's getting, because the algorithm takes that seed and through this procedure will spit out the same random numbers, the same pseudo-random numbers that the professor got. The seed helps determine what number the generator actually selects. And if you want to repeat the same group of numbers, use the same seed. Of course, if you want potentially different groups of numbers, use different seeds. All right, so some examples of a simple random number generation. And here's an example of a simple random sample. We'll consider other methods of sampling later.
Any questions in the meantime? Any questions in the meantime? By the way, one thing about stats class, starts off fairly straightforward. It gets harder near the end. Hang on to your seats. Any questions? Don't want to scare you though. Questions? Let's proceed.
Hi everyone. In addition to simple random sampling, what other forms of sampling might be reasonable to reduce bias? Well, we could try systematic sampling. In systematic sampling, the elements of the population are ordered, and after some point, every kth element is selected, where k could be, for example, 2, 3, 4, 5, and so forth. So for example, we can select every third person that enters a particular bookstore on a particular day. Here, k equals 3. Now, technically, in a systematic sample, a random number generator should randomly select where we start, number 1, number 2, or number 3. Here, let's say that we start with number 3. So we interview the third person who enters the bookstore. We skip the next 2 people, and then we interview the 6th person. We skip the next 2 people, and then we interview the 9th person, and so forth. That's an example of a systematic sample. Remember, one goal is to reduce bias. Let's say that you wanted to interview about 10 students. Bear in mind, we might not be able to predict how many students will walk into the bookstore that day, but let's say we wanted to interview about 10 students. And these were back in the days when students could just walk into bookstores. Would it be wise to just grab the first 10 students who walk into the bookstore early in the morning? Well, that's probably biased towards early morning students, the early risers, and they could have their own characteristics. So a systematic sample might help defeat that kind of bias. Here's an example with the president's ages. Let's say that we select every 9th president to form a systematic sample. K equals 9. Here they form a nice row. Numbers 9, 18, 27, 36, and 45. A systematic sample. Here the ages, the observations would be 68, 46, 51, 55, and 70 years old. Trump was 70 when he became president. In addition to systematic sampling, there's cluster sampling. In cluster sampling, the members of the population are organized into groups. Here in the president's example, we're grouping them by 9s in order. The first 9 for the first cluster, the second 9 for the second cluster, and so forth. These groups are called clusters, and each member is assigned to exactly one cluster. So basically, the 45 presidents here are divvied up among the 5 clusters. Again, we're counting Cleveland twice. And then the clusters themselves are randomly selected in their entirety. And all the members of these selected clusters form our sample. So for example, here we've organized the 45 presidents into 5 clusters of 9 each. We could randomly select 2 of the clusters. So a random number generator can randomly pick 2 numbers between 1 and 5 without replacement. You cannot pick the same number twice. Let's say the random number generator gives us 3 and 5. So that means we grab all of cluster 3 and all of cluster 5. So we grab the 9 presidents here, including Cleveland twice, and the 9 presidents here, and we have a sample size of 18. So a cluster sample is sort of like if you go to a barbecue and you grab a couple of big slabs of meat, or for you vegans, maybe a couple of cucumbers. So cluster sampling is like going to a barbecue and grabbing big slabs of meat. Stratified sampling is more like going to a buffet. A little bit here, a little bit there. In stratified sampling, the members of the population are organized into groups called strata. And each member is assigned to exactly one stratum. So far, it sounds like cluster sampling. And in fact, here, the strata here, the plural is strata, the strata here are the same as the clusters from the previous example. Now, bear in mind, in practice, the nature of the grouping in stratified sampling is supposed to be more meaningful than in cluster sampling. For example, in a stratified political poll, like do you approve of President Trump, the population of voters may be divided into strata, maybe based on income level. Now, here, instead of clusters, they're called strata. And what's another difference with stratified sampling? Within each stratum, the members are randomly selected. And the selected members from the various strata form our sample. So again, instead of cluster sampling, which is like grabbing big slabs of meat at the barbecue or cucumbers at the vegan party, in a stratified sample, you pick maybe 2 from here, 2 from here, 2 from here, 2 from here, and 2 from here. It's a buffet. A couple here, a couple there, a couple there, a couple there, a couple there. So here we've organized the 45 presidents into 5 strata. Within each strata, we randomly select 2 presidents, and then the 10 selected presidents from the 5 strata would form our sample. Now there is some logic to the strata. Remember that there should be some meaning. The chronological grouping could be justified by the fact that medicine has generally advanced over the years, and perhaps it's the case that the later presidents maybe have lived longer, and maybe they can become president at more advanced ages. Maybe. It is true that some of the older presidents, like Reagan and Trump, they were in the last strata. Okay, so let's look at some examples. Let's see if you can tell the difference. Identifying sampling methods. For each scenario below, determine whether the sampling method used is closest to simple random sampling, systematic sampling, cluster sampling, or stratified sampling. Let's go one by one. A teacher walks around a classroom and selects every 4th student to go up to the board. B, a teacher has 30 students in a classroom. The teacher holds a bag with 30 poker chips. The chips are similar, except that 5 of them are green and 25 of them are brown. Each student randomly selects a chip from the bag without replacement. Chips are not returned into the bag. The 5 students with the green chips will go up to the board. C, a classroom consists of 6 rows of students. 2 of these rows are randomly selected, and the students in these rows go up to the board. D, a classroom consists of 6 rows of students. 2 students from each row are randomly selected. All 12 students go up to the board. And E, a high school classroom consists of 4 class levels: freshmen, sophomores, juniors, and seniors. 3 students from each class level are randomly selected. All 12 selected students go up to the board. I'll give you a minute to think about this.
I'll give you a minute to think. I'll also chat along the way. Any questions?
All right. A teacher walks around a classroom and selects every 4th student to go up to the board. That's the example of systematic sampling. I'll shrink this and move this up. All right. B, a teacher has 30 students in a classroom. The teacher holds a bag with 30 poker chips. The chips are similar, except that 5 of them are green and 25 of them are brown. Whoops. Each student randomly selects a chip from the bag without replacement. The 5 students with the green chips will go up to the board. I showed you that's simple random sampling. I'm not doing good with cover up here. C, a classroom consists of 6 rows of students. 2 of these rows are randomly selected, and the students in these rows go up to the board. That's cluster sampling. D, a student consists of 6 rows of students. 2 students from each row are randomly selected. All 12 selected students go up to the board. That's a buffet, a little bit of each. Stratified sampling. E, a high school classroom consists of 4 class levels: freshmen, sophomores, juniors, and seniors. 3 students from each class level are randomly selected. All 12 selected students go up to the board. Again, this is stratified sampling, where actually the strata are more meaningful. So it's a better example. Each class level of students is a stratum. This may be a better example of stratified sampling because the division of students by class level may be more meaningful. All right, next up, we have our sample. What are appropriate and inappropriate questions to ask them? Next time.
All right, and let's do something really cool now. All right. Okay, so let's do something really cool. I'm going to pause this and show you a clip from the movie Bernie. Let's proceed. This is fun.
Hi, everyone. Let's talk about biased samples and biased questions. Feel free to read this here. I won't test you on this per se, but let's go to a fun polls handout. It's an old handout, but it's still fun. All right, polls. Issue 1, do people lie to pollsters? Yeah, they do. Sure, I go to church. In a telephone poll of Roman Catholics in one county in Ohio, 51% of respondents said they attended church in the week before the poll. Actually, only 24% did. And I hear that they do count. Pretending to be devout. Example 2, are people now more honest in polls involving minority candidates? Because back in 1989, there were a couple of major victories by 2 African-American or Black politicians, both Democrats, for New York City mayor and Virginia governor. In the polls, they were both leading by double digits, but they both won squeakers on election day. And this effect is sometimes called the Wilder effect after the Virginia governor-elect, or the Bradley effect after a gubernatorial candidate in California. So back in the 1980s, maybe people weren't so honest, and Black candidates tended to overpoll. But Barack Obama did pretty much perform according to the polls in 2008, so perhaps we're not seeing this as much. But it has happened. In 2003, Bobby Jindal, an Indian-American Republican, underpolled and lost to the Democrat. So you wonder how honest people are when minority candidates are involved. Perhaps it has gotten better in terms of accuracy. Oh yeah, I voted for him. In 1992, Bill Clinton won 43% of the vote for president. But in a poll taken after the election, 50.4%, a majority of the respondents, claimed they voted for him. And by the way, later on, we'll talk about these issues of whether that's statistically significant. Do we have evidence that they really lied, basically, in some sense? But I don't know, maybe people are afraid of the new president-elect. The hidden vote. In political circles, there's often talk of a hidden vote consisting of supporters of a controversial candidate. And actually, there is some speculation that there might be a hidden vote for President Trump. Issue 2, watch out for phone-in, mail-in, and log-in polls. Basically polls where you select yourself as a respondent. That's the problem of self-selection. In a self-selected sample, potential respondents themselves decide whether or not they were included in the sample. So who decides who's in the sample? You do, as the respondent. That's not good. We know that big samples in unscientific polls can be less accurate than small samples in scientific polls, because the big samples might involve unscientific polls that involve self-selection. Here's a big example. In fact, there are several problems with this kind of poll. The most famous Bosch poll in history. Famous. You find this in all stats books. In order to predict the outcome of the 1936 presidential election, the Literary Digest, doesn't sound familiar, huh? It's because they closed down after this ridiculous poll result. The Literary Digest mailed ballots to 10 million people. About a quarter of them, 2.4 million, responded. The Literary Digest claimed that the country will know to within a fraction of 1% the actual popular vote of 40 millions. Well, that might have been true if it were a scientifically selected sample, but it wasn't. First of all, what did the poll say? The poll said that Alf Landon, the Republican, would defeat the Democrat, Franklin Roosevelt, by a solid 14% margin. Ever hear of President Alf Landon? There was none. He lost. In fact, he won 2 states, Vermont and Maine. Actually, Franklin Roosevelt won by a huge 24-point margin, one of the biggest margins in history. Massively botched poll. After the election, the Literary Digest had a cover that exclaimed, "Is our face red?" and soon went out of business. So what went wrong? Well, the non-response bias, the fact that only a quarter of the 10 million people responded. By the way, the Harris poll says the refusal rate is normally 20%. Here, the refusal rate was about 3/4. The census also has a problem with non-response. But it wasn't just that. It was also the problem of self-selection, the fact that people selected themselves to take part. So maybe enthusiasm was a part of it. Also, there's the problem of selection bias. How were the 10 million people selected? The ones who were given surveys. The list of 10 million potential respondents, the ones to whom ballots were mailed, were drawn up from phone books, magazine subscriptions, and club memberships. Things only wealthier people had. Now remember, this was in 1936. What was the country like in 1936? We were in the midst of the Great Depression, and you really had to be wealthy to have the luxury of having these things, okay? Even a phone, a club membership, right? The Gallup poll only polled 50,000 people, which is huge by today's standards, and at least they predicted that FDR would win. Beware of self-selection. Phone-in polls. 186,000 Nightline viewers paid 50 cents a piece to call a phone number to say whether or not the UN should stay in the United States. 67% of them wanted the UN out of the United States. But in a scientific poll, which I bet was closer to accurate, 72% of Americans wanted the UN to stay in the United States, even though it only had 500 respondents. Again, I'm guessing that was more accurate. It probably was. Beware of internet polls. The following quick vote internet poll, posted at CNN in March 2001. Do you celebrate St. Patrick's Day? Of course, I'm Irish, 22%. Well, Irish Americans may have enthusiastically logged in. Irish Americans, and maybe some Irish citizens of Ireland, were probably overrepresented. Irish Americans only represent 7 to 8% of Americans. The 22% was an overrepresentation, unless you had a whole bunch of people from Ireland itself, perhaps. Beware of fans. Quick vote poll on CNN.com. They used to love these things. On January 24th, 2004, are you a Mac fan or a PC person? Mac fan, 20%. Probably an overestimate. Okay, Apple Computer makes Macs, and Apple's market share, at least at that time, was a paltry 3 to 5%. But it's a very committed 3 to 5%, including me. And by the way, this date, January 24th, 2004, it's a special date. It was the 20th anniversary of the Mac. So Mac fans were especially enthusiastic. This could be the world's dumbest poll question, the day before that. Do you vote? Yes, 95%. Come on. What's wrong with this? Bias towards people who tend to vote. Well, by definition, if you voted in this poll, you just voted. Okay, self-selection, all that jazz. If you self-selected, you voted. Okay, the poll is obviously biased towards regular voters, and it should have been yes, 100% by definition, really. Poorly worded questions. Should the death penalty not apply to the mentally retarded? What, huh? So if you tend to be anti-death penalty, how should you vote? It's hard to tell because it's almost like a double negative. If you want an accurate poll, you want to avoid double negatives and confusing poll questions. For example, people who oppose the death penalty would tend to say, yes, should the death penalty not apply to the mentally retarded or mentally disabled, they would tend to say yes. They're supposed to say yes if they're against the death penalty in general, but they might be confused. And these quick vote polls are worthless anyway. Self-selection. Wording a poll question in different ways. Sometimes order matters, sometimes it doesn't. A poll in Germany asked basically the same question in two different ways, presumably to different samples. Number one, would you say traffic contributes more or less to air pollution than industry? Or, number two, a second sample was asked, would you say industry contributes more or less to air pollution than traffic? Really the same question, but the two words here were switched. And yet, very different results. If traffic is mentioned first, it's declared to be more of a contributor to air pollution by 21-point margin. If industry comes first in the wording, then it, quote unquote, wins by 25-point margin. So order really mattered. This is probably the case if people don't really care. It's like, yeah, whatever you said first. They didn't really care. Here's my question to you. If we were asking an election poll and you ask a sample, are you for Trump versus Biden? And you ask another scientifically selected sample, are you for Biden versus Trump? Do you think that the order would really have a profound impact on the results? I don't think so, because people generally care if President Trump wins or if Joe Biden wins. Right. Oh, I use this word Trump. Strength of opinion may well trump order in major political races, though, like in Trump versus Biden. Now, in the 2003 recall election for governor of California, a lot of eyes were on Arnold Schwarzenegger. A lot of people were eager to vote for Arnold Schwarzenegger. But still, people were curious what order he would be on the ballot. About 250 people ran for governor in that recall election. And in order to be, quote unquote, fair, lettered balls were randomly selected from a rotating bin to help determine the order of names on the ballot. And everyone was waiting for S for Schwarzenegger when that would show up. So if you're really passionate about Arnold Schwarzenegger, it didn't matter if he was first or last, really. Leading or biased questions. In the 2000 presidential primaries, John McCain complained about push polling by the George W. Bush campaign in South Carolina. People were asked if they would vote for McCain if they knew he was mentally unstable, had a mixed-race child out of wedlock, and had an alcoholic wife. By the way, I'm not saying any of these was true. Now, some polls, even push polls, start with a clean question for informational purposes, because you might really want to know what the state of the race is. And then they test out various themes for the internal use of the campaign to see if one push topic would work in a campaign ad, for example, or if it might not work. And then at the end, you might ask, are you for this candidate or that candidate? And then see how the results change. Speaking of other push polls, or actually, maybe not so much a push poll, but the wording did matter. Okay, in one poll around 1996, when people were asked if they supported a flag-burning amendment to the Constitution, the percent that said support was in the high 70s. But if you add one more bit of information, if they were informed that it would be the First Amendment to limit or curtail the First Amendment to the Constitution, the percent support drops to the low 40s. And people actually cared about the flag-burning amendment back in 1996. I remember. Even though I was 1 year old. Just kidding. But yeah, even for an issue people care about, if you add additional information, that can have a dramatic impact on the results, the poll results. If you state the purpose, that can have a similar effect. Ross Perot, I'll talk about him later. He was a presidential candidate in 1996, independent. A mail-in survey conducted by the Ross Perot campaign asked, should the president have the line item veto to eliminate waste? They're stating the purpose of the line item veto. 97% said yes. But in a scientific poll, or the random sample, should the president have the line item veto or not? And by the way, this is not self-selected like the mail-in survey was. Should the president have the line item veto or not? Only 57% said yes, a 40-point drop. In fact, a lot of people might not know what the line item veto is, right? And they certainly weren't told that the purpose was to eliminate waste. By the way, the idea of a line item veto is the idea that the president could strike out certain parts of the budget and pass the budget overall without it. Would you say more likely to this push poll question? Please tell me if you would be more likely or less likely to vote for Roy Romer if you knew that Governor Romer appoints a parole board which has granted early release to an average of 4 convicted felons per day every day since Romer took office. Yeah, I think this was a push poll. This was a push poll to try to get people to vote against Romer. He later became school superintendent in Los Angeles. All right. Quick vote internet poll. One of these garbage vote-in polls at CNN.com on October 10th, 2001. Is Al-Qaeda sending coded messages to followers via video statements? 79% said yes. Look at that date. October 10th, 2001. I know some of you weren't born then, but think about it. What do you think the mood of the country was back then? I remember back then. That wasn't even a month after 9/11, that terrorist attack. So yeah, Al-Qaeda would have been accused of doing anything. Sending out video statements, kicking little puppies, you name it. Al-Qaeda was to blame for it all. The ending of Game of Thrones, if it had happened back then. I thought that was okay. Sensitive surveys. If we worry about getting honest answers to sensitive questions, such as sexuality or health, we could inject an element of randomness, such as a coin flip. For example, if I were to ask you, do you have coronavirus? If you have coronavirus, please say yes. But even if you don't have coronavirus, flip a coin. If the coin comes up yes, go ahead and say yes. I have coronavirus. And this is a way of sort of hiding things, so that if someone says that they have coronavirus, then it could be because they actually do have coronavirus, or it's because of the coin flip. So it's a way of covering up for things. And you can adjust the results based on the nature of the element of randomness, like the coin flip. You can adjust the results accordingly so that they're more accurate. Sampling error is natural. Even if the polling methodology is excellent, the sample results may lead you astray. Even well-designed polls are subject to sampling error, and sometimes you're just unlucky. I'll give an example, all the way down here. Well, okay, well, I'll mention that. So bottom line is, if a poll says that a candidate is going to get 47% of the vote, and the candidate actually gets 46% of the vote, that could well be due to sampling error. We'll talk about that later in Inference. In defense of polls. Okay, here's a mad letter by a corporation president to the AP. When you or anyone else attempts to tell me and my associates that 1,223 persons account for our opinions and tastes here in American, I get mad as hell. How dare you? When you or anyone else tells me that 1,223 people represent America, it is astounding and unfair and should be outlawed. Well, this person could be a corporation president, obviously did not take statistics or pass it. Because actually, regardless of the population size, as long as it's much bigger than the sample size, it doesn't matter what big N is. Little p, the underlying proportion of voters who say are going to vote for Trump, okay? It's an underlying proportion that's there, okay? And it doesn't matter what big N is. What matters is how large little n is. It doesn't matter how big N is, as long as it's a lot larger than little n. It doesn't matter how big N is. Okay, it's like little p is this reality, and you're trying to get at it. The bigger little n is, the more you're getting at it. The idea in statistics is that you're more likely to be accurate in terms of getting at what the value of p is. We'll talk about sampling methods and how they're used to estimate p later on, a proportion. Now, statisticians are irritated by the fact that polls don't mention that typically the confidence level is 95%. So, though it's rarely stated, and it should be. Which means that if the margin of error is 3%, okay, that means that we're 95% confident that the actual result is within 3% of the stated result. For example, the Nielsen's, which deal with TV viewerships, handle 4,000 households, and the margin of error is less than 1% for 95% confidence. Okay, so that's the assumed confidence level, 95%. We'll talk about that later. And again, speaking of sampling error, sometimes even when we try our best, the polls are sometimes wrong. Famous headline, Dewey defeats Truman. Remember President Dewey? Like President Landon, there was none, okay? In the 1948 presidential election, the pre-election polls had New York Governor Thomas Dewey, the Republican, way ahead of incumbent Harry Truman. But in the end, Truman won. And this photo became famous. Truman here is smiling because he knew he actually won. Ha ha. Sometimes the polls are wrong, even when we try our best. All right, well, we're going to try to get it right in this class, but be humble. Until then. All right, so you can do the homework for lessons 1 and 2. It's pretty short. I'm not trying to bombard you with homework. It's to get the point across. It's very efficient. All right, any questions, comments? I felt like this day went okay. Any questions or comments? All right, remember, I'll put these up on YouTube, and you have a little bit of homework to do, right? Try to do it before Wednesday. I'll see you on Wednesday. Any questions? Any questions? Okay, yes. Yes, send homework to email. Not now. Okay. Okay. The due date is in September, but keep up. All right. Oh, no. Let's see. Okay. Okay, homework assignments on the PDF. Lesson 1 and 2 homework due in September. That's correct. Can you show the homework? I can. It's on my website. Okay, so Math 119 website. Homework assignments. Number 1, homework for lessons 1 to 10. Right here. So 1 and 2, very short. That's it. Try to do that by Wednesday, though I won't collect it Wednesday. All right, and there's also a landscape version to save paper. I'm not trying to bombard you with homework. All right. Yeah, you can leave. Go home or stay home, whatever. Well, you're welcome to stay. No. You're welcome to ask questions. Yeah, I just saw Birds of Prey, where near the end, Margot Robbie says, "Yeah, go home." Yeah, the homework is yeah, do the homework on the website. Not the examples in class. I mean, like when I go over examples in class, that's just in my notes. So you want the homework off my website. Right. I don't know Japanese. My roommate does, and he's white. I'm monolingual, sadly. A little Spanish. I know the numbers in Spanish. I remember that. Yes, I'm excited too. I love stats. Yeah, forgot to mention that. I love stats. Oh yeah. I love Battle Royale too. That was a great action film. Not animation though. Oh, you're welcome. Yes. All right. I'll stick around. By the way, I normally do stick around after class. So when I said go home, I was joking. Any questions about the syllabus, what you have to do? All right. So I'll stick around until the room clears. I'm cool with that. I'm a Nighthawk. No, this is my only 119. Yeah, I'm recording. Oh, thank you. Thank you for reminding me I'm recording. I'm okay with that. I'm not sharing any deep secrets right now. But thanks for reminding me. Yes, always remind me what status I'm in. I am recording. Anything else? Okay, so try to keep up with the homework, but I won't collect it until the day after the homework session, which won't be until September. No, that's a good point, though. Yeah. Remind me if I'm messing up, because someday I'm going to mess up. I'm pausing when I should be recording. I'm recording when I should be pausing. I'm sure I'll do that. Okay, thank you. Okay, anything else? Anything else? All right, so at this time, I'll go ahead and stop the recording. Okay, are you able to give us small email reminders for due dates? No, I think I remember that was a problem one time when students were expecting them and I forgot. So to guard against the fact that I forget sometimes, lean on my tentative schedule in my syllabus, the last page of the syllabus. So assume that that's going to be the set, and I think that'll hold. But and then come to class, or at least view the YouTube videos and keep track of the due dates. All right. But no, email reminders are risky because those are easily messed up, or I forget. Maybe I should stop the recording now. All right. Thank you, everyone.